Good morning, everyone. Welcome to the demonstration of XAS on the Empyrean system. We will walk through the typical setup for XAS and show you a typical measurement on Empyrean system. As we know, Empyrean system is a multi-purpose instrument for X-ray techniques, especially focusing on XRD part. We have the typical configuration called the Braga-Brown tunnel geometry. In this geometry, normally we do the symmetric scan of the measurements. Our XAS technique is invented based on this configuration. Let's have a look about the inside of XAS components. First of all, on the left side, we have the enhanced stability of the tube, which gives the focus spot. And then after that, we have the primary beam, which confines the beam's height and beam width before the beam arrived at the sample stage. When you look at the sample stage part, which is a bit different from the typical XRD measurement here, we have the different options allows from the manual stage to automatic stage. In this case, we have the 5 as crystal stage. In this stage, we can put different crystals on top. Then the stage allows the movement of the crystals in the chi rotation or phi rotation or X, Y, Z movements. So which gives the automatic alignment for different crystals, enables for the measurement of high resolution, high intensity of XAS by selecting different crystals. Then after the cradle, on the right side, we have the diffracted beam path in front of the detector. So the detector is our advanced Wonder detector, which has a new feature and opens up the capability of measuring XAS on a XRD instrument, which makes that diffractometer system unique, and then converting from a diffractometer to a spectrometer. And another advantage of doing XAS on this diffractometer, on this Empyrean system, is that we can do a complete gonal scan to do the measurement from very low angle to very high angle without limit. That makes this XAS solution unique for any applications. For example, you can do a multiple edge measurement for a compound like barium titanate. You can do the K edge and L edge measurements in one go from low angle to high angle. Okay, after showing you all the components of this XAS application on the instrument, I'm going to run a measurement, show you how to do the measurement. I will pick up a sample from here with a prepared list of specimens covering different applications, some oxide and also some materials from battery, some morph material for catalyst. I will pick up this iron oxide compound, which is prepared in the pellet form. I will insert it to not on the normal XRD stage, but to the slot for transmission mode measurement of XAS, which is here. Then, okay, let's now make a measurement program to see how it works on our XAS. This session, we look at the software part. As said, we have a dedicated software called AbraXAS, which in fact, as shown here, loads from sample preparation guidance to tell you how much powder you need to make a sample preparation, to the measurement program generation and execute the measurement, then finally the data processing. Now I'm going to show you how it works. So now in this screen, we have a few tabs for different purposes, from sample preparation to measurement program generation to the measurement and processing. This is a screen for showing you how much powder you required for making the sample. In this case, show the K edge of the iron. So next step is normally we first define the configuration. In this case, we have the copper source, and then use different crystals. As mentioned, we have 3 crystals, but the different reflection can be selected from these different crystals. We have alignment parameters after the alignment of the crystal parameters. And then what's most interesting is the measurement program. Here there are all the XAS capabilities we can do on the Empyrean system, especially if we are interested in our KH. We also can enable the calculation for different reflections. You are aiming high resolution or high intensity in this case. So we're using this configuration for the measurement. Then in the condition, we define the tube, we define the crystal. Then in the detector part, we said we're using the advanced wonder detector to enable the feature of the XAS measurement. We finished all the setting of the parameters. Now we can in effect define where you want to save your data, then give the name of your data measurements. In this case, RN203, the home tight. Then let's run the short measurement of this example. Just click Measure. Then the scan finished. Let's move to the next step. It's about a few minutes to scan and move to the next step for evaluation. In the evaluate functionality of the software, I show the data on the left panel, shows the raw data. They are data I collected beforehand for a bit long range in angle or in energy. So the orange curve is the data measured on the sample. And this one is measured direct beam. And then we make the absorption calculation or normalization, which comes to the data on the right panel, which is an automatic processing procedure in the AbraXAS software, where you can see the lines that define the pre-edge and the post-edge lines, and also other curves, for example, the flattened curve, which is after normalization. With that, you can compare the data to other resources to evaluate or for the analysis. You can also fit data using the FAF calculation from other scientific softwares.